Day grade 12s, hope the studying is going well. So today I'm gonna be looking at a test that I did with my students the other day. So it's mostly paper 2, so it's gonna be preparation for paper 2, and then the last question here is probability, which is part of paper 1. All right, let's get to it. So first question says ABCD is a quadrilateral with vertices A, B, C, and D. And then the first question says calculate the length of AC, and then you need to leave the answer in simplest set form. So here you're just going to use the distance formula as it is given in your formula sheet. So the distance of AC is going to be equals to x at A minus x at C squared plus y at A minus y at C also squared. This is going to be equals to, so x at A is going to be 2, and then x at C is a minus 4. So negative times negative, it's positive. So it's going to be a positive 4 plus your y at A, which is going to be 5, and then your y at C, which is going to be 3. And then if you work this out, you're going to get, so 2 plus 4 is 6. Okay, so this is going to be 36 plus 4, which is the square root of 40, and then you need to leave the answer in set form. So that's going to be 2 square root of 10. And then let's move on to 1.2. So 1.2, determine the coordinates of M, which is the midpoint of AC. Okay, so midpoint formula is going to be x at A plus x at C over 2, and y at A plus y at C also over 2. This is going to be equals to my x at A is 2, and then my x at C, it's a minus 4. So it's a positive, they put a minus 4 over 2. And then my y at A is going to be 5. And then my y at C is going to be a positive 3 over 2. And then if you work this out, just put it straight into your calculator. Okay, for x you're going to get a negative 1, and then for y you're going to get a 4. Okay, and that becomes your midpoint. And then 1.3 says show that BD and AC bisect each other perpendicularly. So a question of this nature, what you need to do here, you need to know that the two lines which bisect each other perpendicularly, their product needs to be equals to negative 1. So I'm gonna start off by calculating the gradients individually. Let's go. MBD is going to be y at D minus y at B over x at D minus x at B. So what is my y at D? My y at D, I see it's a negative 2, and then my y at B is going to be a positive 10 over my x at D is going to be what? It's going to be 1, and then my x at B is going to be a negative 3, and then negative times negative is positive. And then if you work this out using your calculator, you're gonna get a negative 3. All right, and then now I need to also calculate the gradient of AC. So MAC is going to be y at C minus y at A over x at C minus x at A. Let's substitute. What is my y at C? My y at C is a 3, and then my y at A is a 2 over my x at C, it's negative 4. My x at A is just a positive 2, and then if you work this out, you're going to get, so that's a 1 over, what's this, 1 over negative, no, there must be a mistake here. X at C and then x at B, and then let me just check something. What did I, so y at C is a 3. Oh, it was supposed to be 3 minus a 5 here. Okay, so and then 3 minus 5 is going to be negative 2, and then negative 4 minus 2, which is that's going to be negative 6, and then no, sorry, yeah, that's going to be negative 6, negative 2 over negative 6, which is going to be a 1 over 3 if you work this out. All right, and what do you do next? So now all you have to, you've already proven, okay, so you just have to prove that MBD times MAC is negative 1, of which you can see that it's going to be the case. So MBD times MAC is equals to negative 1. So we can see that negative 3 times a 1 over 3 indeed is going to give us negative 1. So therefore, that means that BD is perpendicular to your AC. Alright.